This is Euclid Book 10, proposition number 95, and if you'll give me a moment to pause, I'm going to take a drink. And we're going to get into this. If an area be contained by a rational straight line and a fifth apotome, the side of the area is a straight line which produces with a rational area a medial whole. Wow, that's a lot of words. For let the area AB, well that's this, be contained by a rational straight line AC, which is this, and the fifth apotome AD, which is that. I say that the side, that's what we're going to talk about here, of the area AB is a straight line which produces with a rational area a medial whole. For let DG be the annex to AD. We got that part. Therefore, AG and GD are rational straight lines, commensurable and square only. Okay, AG is this whole line right here, and GD is this whole line right here from here to here. They are rational straight lines, and they are only commensurable and square. The annex GD, which is this, is commensurable in length with the rational straight line AC set out. So this is commensurable with that. And the square on the whole AG is greater than the square on the annex DG, so this is going to be bigger than that. By the square on a straight line incommensurable with AG, which is by Euclid Book 10, third set of definitions, number 5. Therefore, if there be applied to AG a parallelogram, that's what we're getting ready to do, equal to the fourth part of the square on DG and deficient by a square figure, it will divide it into incommensurable parts. And that's by Euclid Book 10, proposition number 18. Let then DG be bisected at point E. Right there. And let there be applied to AG, which is this, a parallelogram equal to the square on EG. So we're going to make a parallelogram, and it's going to have the same area as EG, which is this, and deficient by a square figure, and let it be rectangle AF and FG. Okay. So this parallelogram right here is equal to the square on EG and deficient by a square figure, etc., etc. Therefore, AF is incommensurable with FG. AF and FG are incommensurable. Now, since AG is incommensurable with length with CA, since this whole length is incommensurable with this, and both are rational, therefore AK is medial. Alright. AK, which is this plus this plus this plus this whole area here is medial. This is by Euclid Book 10, proposition number 21. And since DG is rational, this plus this plus this, it's rational. And DG is commensurable with AC. This line is commensurable with this. Therefore, DK is rational. This plus this plus this is rational. Now let the square LM be constructed. This is the one here. It's going to be equal to AI. This plus this plus this equals this area. And let the square NO, which is this, be equal to FK, which is that. Alright, therefore the squares LM and NO are about the same diameter. The whole area and this little tiny part are about the same diameter, which is this. This is by Euclid Book 6, proposition number 26. Let PR be the diameter. That's this. And let the figure be drawn. Similarly, then we can prove that LN is the side of AB. We're going to prove that LN is this. Alright? I say that LN is a straight line which produces a rational area and a medial whole. Okay, so now we're going to say that LN is a straight line which produces a rational area and a medial whole. For since AK was proved medial and equal to the squares on LP and PN, okay, so this plus this plus this plus this is not only medial, that whole area is not only medial, but it's equal to this plus this. Okay, so you take this area, you add this area to it, you're going to add these two areas together, and it's going to equal all this. Therefore, the sum of the squares on LP and PN are medial. Okay? You add these two areas together, that comes up to be medial. Again, since dk, well, what is dk? Well, that's this all the way through here. Since it's rational and equal to, okay, since all this is rational and it's equal to the rectangle this, actually it's, okay, hold it. This is all rational here, okay, and that whole area is equal to this multiplied by 2. So if you take this area, you take it times 2, you get all this. The ladder itself is also rational. This area multiplied by 2 is rational. And since AI is incommensurable with FK, since this plus this plus this is incommensurable with that, therefore the square on LP, which is this, is also incommensurable with the square on PN, which is that. So these are incommensurable. Therefore, LP and PN are straight lines, okay? This and this, they're straight lines that are incommensurable in square, which makes the sum of the squares on them medial, but twice the rectangle contained by them rational. Therefore, the remainder Ln, which is this, is the irrational straight line called that which produces with a rational area and a medial whole, which is by Euclid Book 10, proposition number 77. And it is the side of the area AB. So this is this. Therefore, the side of the area AB is a straight line which produces with a rational area and a medial whole. All right. And that's the end of that proof. Aren't you glad that's over with? Alright, we got one more proof we got to use this diagram for. After that, we're done with this diagram. So, I will tell you more in a future video. I want you to stay tuned.